Hi, welcome to the video solution for Cambridge IGCSE Physics past paper. This is IGCSE Physics, May-June 2019, paper 22. So let's start. Question number 1. Which quantity can be measured directly using a micrometer screw gauge? So remember, micrometer screw gauge is used for a very small measurement. Very small measurement like uh, you know uh, a, a paper sheet thickness of a paper sheet, or area of a wire, area of a wire, cross sectional area, in fact. So if you have very small measurement, very small object, you can find the thickness or diameter of a wire, something like that, using a micrometer screw gauge. So the area of the paper sheet we don't need. So you see, in all these options we have a thickness of the sheet of paper. The best suitable device is micrometer screw gauge, so option is C. Question number 2. Four objects are moving along a straight line. The distance of an object from a fixed point on the line is plotted against time for which object is decelerating. So remember, when the object is decelerating, its velocity is decreasing. So if you see, we have a 4 distance time graph, and remember, in general you say if you have a distance time graph, then gradient of this graph gives you speed. So gradient gives you speed. Now if you see option A, you see that in option A we have a straight line. That means we have constant gradient. Constant gradient because of the straight line. That means speed is not changing. Speed is constant. Speed is constant. Same for option D. We have a straight line. That means again for option D we have a constant speed because of the constant gradient. Constant speed. That means you can exclude option A and option B immediately. We need to think whether we choose option B or option C. While they are saying that the object is decelerating, so that means velocity should be decreasing. And because of the gradient of the graph, if you see for B, if you move along the curve, you see the gradient of the curve is increasing. Gradient of the curve is continuously increasing. That means this is the graph of speeding up or accelerating motion. That means car is moving or object is moving with increasing velocity or accelerating. Here, as you move along the curve, the gradient of the curve is decreasing. That means speed is decreasing, so the object is decelerating. That means your option is C. Question number 3. A heavy metal ball falls vertically downward through air. Pass for equally spaced level J, K, L, and M. Okay, we have a metal ball falling freely, J, K, L, M, equally space interval. The time taken to fall from one level to the next level are measured. Where is the speed of the ball greatest and which time is shortest? Clearly, for free fall motion, if object is falling freely, that means it is speeding up. Speeding up. So speed is increasing at the rate of 9.8 meter per second square. This is the rate of increase, which is called acceleration due to gravity, value of a small g. That means at that point velocity will be 0, and when the ball reaches at J, its velocity is increased from 0, and then K velocity is increasing even more and more and more. That means at level M, at level M, particle will be moving fastest. So between L and M, particle will be moving fastest. That means speed is greatest between J and K and J and K. So you can ignore immediately A and B option. So L and M speed is greatest in this interval. What about the time is shortest? Of course, because speed is increasing continuously, so time taken to reach the next level will be decreasing, meaning because the particle has reached some maximum velocity at level M and is increasing more, so it will take least time compared to the all above level. So the time is shortest in the even the last interval. So again we have a time shortest in L to M interval, so the option is D. Question number 4. Four students make statements about the mass of an object. Which statement is correct? It is all about a statement about mass, remember. So the mass of an object depends on gravitational field. No. Mass, remember, mass of an object stays the same, because mass is nothing but quantity of matter in an object. So no matter where you take the object, the quantity of matter stays the same, so it does not depend on gravitational field. The mass of an object divided by its weight is equal to acceleration due to gravity. Of course this is a wrong statement, because if you see the relation between weight W and the mass M, we have a relation W is equal to mg. And what are they saying? They are saying mass is divided by W. So if you mass divided by W, if you rearrange this equation, mass divided by W will be 1 upon G. It is not a G, it is 1 upon G. So this is a wrong statement. The mass of an object increases when the temperature, of course there is no such relation between mass and temperature, so ignore C. Mass of an object resists change in motion of an object. Indeed, this is the correct description of mass. In fact, this is description is giving about the idea about the inertia, because inertia is measured of mass of an object. So inertia or inertial property, mass is inertial property or inertia, whatever you say. So option is D. Mass is the measurement of resistance in any change. Question number 5. A metal has a density of 8 gram per centimeter cube. A solid cube of a mass 1 kilogram is made from this metal. How long is each side of the cube? So we need to find the side of a cube. So if you see, if you have a cube like this, so if this is length L, this is L, and this is L. So because of the cube, all length, width and heights are equal, and they are saying density is 8 gram per centimeter cube and mass is 1 kilogram. So we know that we have a formula of density. Density D is equal to mass over volume. The idea is, because we need to find the side or the length of each side, so we need to find the volume first. So V is equal to V is, if you rearrange this equation for V is equal to mass over density. But before substituting the value in the formula, make sure that they have the same unit. Density is given in gram per centimeter cube. This is CGS system. And the mass is given kilogram, SI system. So we will convert this kilogram into gram by multiplying by 1000. So if you do that, the mass will be 1 times 1000, that means 1000. So mass is taken as 1000 gram, and I will substitute 1000 gram in the formula. So V is equal to 1000 divided by density, which is 8. And if you solve this equation, then V is equal to 125 centimeter cube. This is the volume, and we know that this is the cube. This volume is L cube, length into breadth into height. So L cube is equal to 125 centimeter cube. Because we need to find the length, so we need to take cube root. So how do you do that? So L cube, I'm just doing in detail. If you know what I mean, you can skip all the step, but for your understanding, so L cube is 125, and 125, and if you need to find L, so you will take the cube root. That means you take power 1/3 on both sides. This is the cube root. You use your calculator, so you can find the cube root. So 3 and 3 gone, so L is equal to cube root of 125, which is 5. That means length is 5 centimeters, so your option is C. Question number 6. An experiment is carried out to determine the spring constant for a spring. Different loads are hung from the spring and its length is measured for each different load. The graph shows how its length varies with load. So this is the weight and this is the length of the spring starting from 4. What is the value of the spring constant? So we have a weight and length graph. In other hand, we have force and extension graph. So if you have a force extension graph, and if you have a straight line, then remember, gradient of this graph, that is rise over run, gives you value of k, or the spring constant. So gradient is a spring constant. So what do you need to do? You just need to find the gradient of this line, and this gradient will give you a spring constant or value of k. Sometimes it is also known as stiffness. Remember, this is also known as a stiffness of the spring. Okay, so you need to find the gradient. So gradient would be equal to rise over run. So rise, you will take 2 points on the line. You can choose any 2 points, but I'm choosing these two because these are the easiest one, and clearly the coordinate of these points are 20, 4, and coordinate of this point is 4, 0. Now the gradient will be y2 minus y1, in this case 4 minus 0, divided by x2 minus x1, so 20 minus 4, x2 minus x1, so 4 over 20 minus 4 is 16, and 1 upon 4, and 1 upon 4 gives you 0.25, and that means gradient is 0.25, and this gradient is basically k, a spring constant. So answer is 0.25. So option is B. Of course, unit is Newton per centimeter, because this is Newton and here is centimeter. So rise over run, Newton per centimeter. Question number 7. A beam is pivoted at its center of mass. It is acted upon by two forces, 10 Newton and 5 Newton, as shown. Okay, so we have a pivot, 5 Newton and 10 Newton, 25 centimeter is this length, 15 centimeter is this length. So what is the resultant moment about the pivot? Okay, so we need to find the resultant moment. If you see, we have a pivot here and this is the rod, distances are given, so this force is acting upward. That means about this pivot the 10 Newton force is going to create a clockwise moment, clockwise, and this 5 Newton force is going to rotate the rod about the pivot anti-clockwise. So first we are going to find the individual moment, like what is the clockwise moment and what is anti-clockwise moment. If both moments are equal, then the rod will be in equilibrium, but we know that they cannot be equal because they are asking us find the resultant and we don't have any zero option here. So both the moment cannot be equal. So let's figure out first clockwise moment. Clockwise moment, I am finding clockwise moment, and the 10 times, so clockwise moment would be equal to, so moment would be equal to force 10 times pivot distance, and pivot distance we need that distance for clockwise moment. Clearly this is 25 minus 15, and 25 minus 15 is 25 minus 15 is 10 centimeter. So 10 times 10, that means 100 Newton centimeter, and direction is clockwise. So this is 100 centimeter. And now we are going to find the anti-clockwise moment. So anti-clockwise moment is equal to 5 times pivot distance, which is 15. That means this is 75 Newton centimeter. So resultant moment would be equal to 100, which is the clockwise moment, minus 75, that means 25 Newton meter, and this 25 Newton meter resultant will be clockwise moment as 100 is greater than 75. So clockwise moment is greater, so resultant should be a clockwise. So 25 Newton centimeter, I guess I said Newton meter, it's not Newton meter, it is Newton centimeter. So the resultant will be 25 Newton centimeter clockwise, so option is B. Question number 8. Which object is in equilibrium? Clearly, if you see that this object, the resultant force of these two forces will be in that direction, so it will not be in equilibrium. These two forces are opposite and equal in magnitude, but they are going to rotate this object. Again, this object will be moving in that direction, two equal and opposite direction, and line of action is same. So again, this is two equal and opposite forces, but line of actions are different. This force is acting in that direction, it is acting in that direction, so the object will not be in equilibrium, it will be rotating about that center. But two equal and opposite forces, line of action is exactly same, acting in a line. That's why object C is in equilibrium. An object of mass 4 kilogram is moving with a velocity of 3 meter per second in a straight line. What is the momentum of an object? A straightforward question. Momentum P is equal to mass into velocity. So you say 4 times of 3, that means 12. 4 times of 3, 12 kilogram meter per second. Option is C. Question number 10. A machine is very efficient. What does this mean? It produces a large amount of power. It uses very little energy. It wastes very little energy. It works very quickly. So if you see, the efficient comes from the word efficiency. Efficiency, and efficiency is all about how much output against the input. That means it's all about how much energy from input is being converted into output. So efficient is all about very less amount of energy should be wasted. So there's nothing to do with the power and the use of little energy. It doesn't matter how much energy is used. It's all about how much output power, how much output energy or power we get from some machine, or how much a small amount of energy is wasted. So it's all about efficient mean how a small amount of energy is wasted. So option is C. 11. A force F acts on a body and the body moves a distance d in the direction of the force. Which expression for the work done W is correct? Clearly, it's again a straightforward question. If you know the definition of work, what is the work? Work is if force is acted on an object and due to which object covers some distance. So force into distance, this is general definition of work. So you say W is equal to force into distance. This is the definition of work, and from this definition or formula, clearly option is A. Question number 12. A boy produces an average power output of 60 watt as he rides his bicycle 2 minutes. How much useful energy does he expend? So it's all about power. So we know that the formula for power P is equal to work done upon time, or you can say power is energy upon time. So if you need to find how much useful energy does he expend, so you need to find energy, that means you need to find E. For E, you make E as a subject, so E is equal to P into T. So P is the power, which is 60 watt given here, and T is the time, which is 2 minutes, but minutes should be converted into seconds, so multiply by 60. And clearly 6 times 6 is 36, 36 times 2 is 72, and 2 zeros are there, so 72 joule. This is the energy that the boy expend during bicycling, so option is D. Question number 13. The diagram shows a stone suspended on a string under the surface of a liquid. The stone experiences a pressure caused by a liquid. What would increase the pressure on the stone? So it's all about pressure due to liquid. Due to liquid, or sometimes they might say fluid. Any types of fluid, liquid or fluid. So remember, pressure due to fluid, P is equal to rho G and H, where rho is called density of the liquid, G is acceleration due to gravity, which is 10. Generally we take the value of 10 gravity. H is the depth. So if you see the stone is in a liquid which has some density, it doesn't matter where you put the stone, density is not going to change. So pressure is only going to depends on the depth, how deep the object is. So if you see, decreasing the surface area of the stone, there is nothing to do with the area of the stone. So pressure only depends on depth if gravity and density remains the same. So there's nothing to do with the area. Increasing the mass of the stone, mass is not involved in this equation. So lowering the stone deeper into the liquid, clearly if you lowering a stone down, that means you are increasing the depth. If depth is increased, then pressure is increased. So that's how pressure on a stone is increased if you lower the stone into the liquid. And using a liquid with a lower density, of course, if you decrease the density, so pressure is going to decrease. So this is not the option, because you need to tell the pressure, the reason of increase in the pressure. So lowering density causes lowering the pressure, not increase in the pressure. So only option is C, because you are increasing depth. Question number 14. At room temperature, iron is difficult to compress. At the same temperature, oxygen is much easier to compress. Which comparison of the structures of iron and oxygen explain this? It's all about compression of two different material, two different states. Iron is solid. Iron is solid, and oxygen is gas, because they are at same temperature, or the room temperature. Room temperature, iron is solid and oxygen gas. Clearly you know that in solid, particles are compact. There are not much space between the particles like these, and they cannot move. They are just oscillating at their place. So you cannot compress solid. But gas, particles are you know further apart, and they are moving rapidly here and there, so you can compress these particles easily. So it's all about distance between the particle. So the iron particles are closer together, the iron particles have greater masses, the iron particles can be magnetized, the iron particle can have a less. So there's nothing to do with the magnetism, there's nothing to do with the greater masses, and of course there's nothing to do with the kinetic energy. Clearly the iron particles are closer, so they cannot be compressed. That's what the option A is. Question number 15. At a night storage heater contains a large block of material that is heated electrically during the night. During the day, block cools down, releasing thermal energy into the room. Which thermal capacity and which nighttime temperature increases will cause the most energy to be stored by the block? So if you need to store energy in some object, store energy in some object for the in terms of thermal energy, that means the object must have high thermal capacity. That means high thermal capacity, high thermal capacity means it can absorb a large amount of heat. It can absorb a large amount of heat. So if you need to store more energy, so thermal capacity should be higher. That means option C and D are immediately gone, because thermal capacity of the block should be large or higher. That means either option A or option B. And then of course which time, so nighttime temperature increase, so it should be the large increase in the temperature, so that it can transfer more energy. So there is a large increase in temperature, that means it can absorb more energy. So the option is A. Question number 16. 100 100 gram of water at 25 degrees centigrade is poured onto an insulated cup. 50 gram of ice at 0 degrees centigrade is added to the water. The water is stirred until the temperature of the water has fallen to 0 degrees centigrade. 18 gram of ice remains unmelted. The specific heat capacity of water is 4.2 joule per gram per degree centigrade. Which value does this experiment give the specific latent heat of fusion of this of ice? So idea is, if you have a cup in which you put 100 gram of water initially already there, and this 100 gram of water is at 25 degrees centigrade, and then you are putting a piece of ice, 50 gram of ice, in this water, in this cup. So what is happening here? In fact, you can think heat energy, because the water around the ice is hotter than the ice. So heat from the water is going to absorb into the ice, and thus then ice is going to melt. So in this process, water is losing heat. That means the temperature of the water is decreasing from 25, and you stir the system or the water until the temperature decreasing from 25 to 0 degrees centigrade, and that's what is happening. And in that moment, when the temperature has fallen from 25 to 0, so heat is absorbed from water to the ice, and the ice is melting due to that heat. And at the end, 18 gram of ice remains unmelted. So the idea behind this question is the heat released by the water. So you must think about this about this question like heat released by the water equals heat absorbed by the ice. So heat released by the water is equal to heat absorbed by the ice. So first we need to find how much heat is released by the water. So if you need to find heat released by the water, so we have formula Q is equal to mc delta T, where m is the mass of an object which is releasing heat or absorbing heat, and c is the specific heat, delta T is the change in temperature. So heat is released by the water, so mass of the water is 100 gram, specific heat C is 4.2 joule, this is value of C. So multiply by 4.2 joule times change in temperature delta T. So initial temperature was 25, and until it has fallen to 0. So change in temperature is 25 minus 0, that means 25 degrees centigrade. So this is the change in temperature. If you solve this, you will get 10500 joule of energy. So this is the energy released by the water, and this energy is being absorbed by the ice, and it is melting. So because ice is melting, and it's all about latent heat of fusion, so we know that Q is equal to latent heat of fusion into the mass. Q is equal to latent heat of fusion and M, and this Q is the heat absorbed during melting process. So we need to find latent heat of fusion. So latent heat of fusion, LF, is equal to, you can send M on the other side, Q divided by M, and this Q is the heat absorbed by the ice, which is as same as heat release. So Q is 10500 divided by mass, and this is the mass which is being melted. So initial mass was ice was 50 and unmelted was 18. So the the mass which melts during this process is 50. So this m would be equal to basically 50 minus 18, and it will give you 32. So latent heat of fusion in this case, if you divide 10500 divided by 32, so answer will be equal to 328.125 joule per gram. So 328 rounded off to I guess 330. So your option is B. So your option is B. The handle of metal saucepan is made of plastic. As saucepan heats up, the handle gets warmer. Which statement explains this? Molecule of the plastic radiates their energy to the other molecule. There is nothing to do with the radiation, because in radiation there is no motion of particle involved in there. So radiation is just transfer of heat in the form of radiation. So it cannot be option A. Molecules of the plastic vibrate more and passes to their energy to nearby molecules. Yes, indeed, because the plastic is made of solid. So in a solid, heat is transferred due to conduction process. And conduction is due to oscillation. Due to oscillation, like this particle is oscillating left or right, and when energy is increased, it collide with the next particle and transfer to the energy, and the energy of the next particle increase, it start oscillating violently and transfer energy to the next. So transferring energy due to collision of vibrating particle called conduction, and that's what happening in plastic cape, plastic saucepan, a plastic handle, because it is solid. So your option should be B. But let's see, the free electron, there's nothing to do with the free electron with the heat transfer. The heated molecule are very slowly, no heat is transferred, so of course molecule cannot move it. There is no convection going on. It's all about conduction, energy transfer due to vibration of molecule and colliding with each other. So option is B. Question number 18. The metal surface of kettle is hot. What happened to the cool air outside the kettle when it comes to contact with the hot kettle? So the density of the air decreased, and the air falls. The density of the air decrease and the air rises. The density of the air increase and the air falls. The density of the air is increase and the fall. Of course, when you see air coming contact with some hot object, and you can observe this phenomenon if in during hot weather, if you see roof of your car, if you see, and during hot weather, if you have not observed, then try in coming days. So during hot weather, you see the surface of the a roof, or maybe a front, whatever, because it is a metal. During summer it's getting hot, and you will find the air moving quite faster closer to the metal surface, is due to the high temperature, and density is decreasing and air is rising up. So what happened when air comes in contact, its density is decreased, and due to decrease in density, air starts rising up. So the option is B. Question number 19. Vacuum flasks usually have silvered walls that help to keep the contents of the flask hot. Why are the walls silvered? The reason of silvered wall is because silvered wall is a very good reflector. So the purpose is to absorb thermal energy, to increase the rate of convection inside the flask, to reduce the energy loss surrounding, to reflect thermal radiation. So see, the silvered mirror is all about the reflection because it is a good reflector. So your option is D, because of it can reflect thermal radiation back into the flask. Option is D. Question number 20. When water waves pass through a gap, they diffract. The diagram shows wavefront approaching a narrow gap. In which diagram will the diffraction be least? So remember, diffraction is all about spreading of a wave. The spreading of a wave when passing through a gap. When wave passing through a gap. Passing through a gap. So if size of the gap, size of the gap is equal to or approximately equal to wavelength of the wave, lambda is the wavelength of wave, then it will diffract more. So diffraction will be maximum. But if gap is larger or bigger than the wavelength, so diffraction will be least. So in this question you need to see in which diagram the gap size is greater than the size of the wavelength. So remember, whenever you see the wavefront, distance between two wavefront is in fact showing the wavelength of the wavelength. So if you see that distance and this distance of the gap is approximately same, there's not much difference, so there will be a maximum diffraction. Here wavelength is greater, this is the wavelength which is greater than the gap size, so there will be no diffraction because wavelength cannot pass through the gap. Here the wavelength and the gap is again, they have a same size, so you have a maximum diffraction. You have a maximum diffraction here because gap size is equal to the wavelength. Here you have a no diffraction at all because wavelength is much greater than the gap. So wavelength is greater, that means wave cannot pass through the gap. Here wavelength is smaller than the gap, so these waves can pass through the gap because of the smaller wavelength, but it will diffract least. So your option is C. Thank you very much and have a nice time.